All right, so let's get started. So as I said in the previous video, we are going to start with the libraries, right? So in this particular video, we are going to touch on the various libraries that we have in Python, right? And we're going to start with NumPy, okay? So there are several libraries that we'll be touching on, moving on, right? Move from right from this video to your machine learning class. We'll be touching on different kinds of libraries that we have in Python, right? With respect to this particular video, we're going to touch on NumPy, okay? After this video, we go to Pandas and then Matplotlib, Seaborn, and SciPy, including all the other libraries that is necessary for engineers, data scientists, or machine learning engineers, or AI engineers, okay? We're going to touch on all of that. So, starting with, we'll first start to have an overview of the various libraries that we have. So as I said, there are several libraries that we can actually work with, okay? And we will be touching on, as I said, subsequently, right, in the subsequent video. So I'm not going to go deep into these right now, right? So as we move on, we will pick them and then we'll be talking about them, right? As at when we need them, we pick them and then we talked about them, okay? So if we talk about, I've grouped them over here to make them, simple for you, right? So that when you, depending on what you want to achieve, depending on the project that you're working on, you actually get to know which library to use, okay? All right, so if you see here, I've given you Python library, right? So if you're doing, for example, data collection, right? So the libraries that you need. Talking about data cleaning, there are some libraries that you will need. All right, talking about data visualization, there are some libraries that you need. Data modeling, check interpretability of different models. There are some libraries that you need. Manipulation of audio, there are some libraries that you need. Data processing, there are some libraries that you need. The libraries for each of them. For instance, web deployment, for instance, there are some libraries that you need. So we will be touching on as we move on in the course. Okay, so I've grouped them over here so that it will become quite easier for us as we progress in the course. So not talking too much in this particular video, we are actually going to do with NumPy. So let's start with that. And as I said, we will first touch on NumPy, we touch on Pandas, then we move on to Matplotlib and then Seaborn, right? So then we talk about web scraping using Beautiful Soup and other libraries that we are also going to consider. We're not only going to stick ourselves to Beautiful Soup, there are other awesome libraries too that I will introduce you to. Okay, so let's start with NumPy. Okay, let's start with NumPy and then move on with this particular tutorial. Okay, now talking about NumPy, all right, talking about NumPy, the name NumPy over here, as you can see over here, this name NumPy, right, as you've been hearing, I assume that you've been hearing NumPy over and over again. It's nothing but numerical Python, right? So numerical, right, just for manipulation of numbers. Okay, it's actually used for the manipulation of numbers. So that's where the name is actually coming from. So numerical, right? So the num is actually for the numerical, and then the pi is for the Python. Okay, so that's where the name is actually coming from. All right, so the most important thing about this NumPy is that we are able to use NumPy for n-dimensional array, right? That's number of arrays, right? So it could be a 2-dimensional array or it could be a 3-dimensional array, right? So NumPy actually help us to work on such arrays very efficiently. All right, that's why NumPy is actually being preferred. It's one of the preferred libraries in Python. Okay, and as we progress in the course, you'll get to understand why we need arrays and why we need NumPy to work on these arrays. Okay, how we are going to use this NumPy to even generate the arrays. We're going to actually deal with it in this particular tutorial. All right, I've also given you a link here, right? We will be visiting the NumPy documentation, right, quite frequently, right? So if you need any information, if you need anything to, if you want to read more about this NumPy, the best place to go is the NumPy documentation. All right, so I've given you a link here that you can just click on it and then you go to the documentation, and there's a lot of information that you can actually get over there. Okay, there's a lot of information that you can actually get over there. Now let's move on and then start doing something here. Now, talking about libraries, right? Talking about libraries in Python. I mean, in Python in general. Okay. If you want to use any library in Python, so Python itself is a programming language, as we've been discussing from the first videos all the way to this one. Okay, it's a programming language. Now, the what makes Python more preferred is the various libraries that we have, right? The various libraries that we have. So libraries are nothing but some extensions that we have that we can actually add to this Python language to make it more powerful, right? So if we talk about just think of a library as an SD card or as an external drive where you can store a lot of your information on it. Maybe you have a laptop, right? So if you have a laptop and then this laptop is having the memory of the laptop is actually full, right? What do? You buy an extension, right? Then you connect it to it, right? You buy an extension, then you connect to it. So now you can actually save your files on this extension. So now this extension is making your laptop powerful again. Otherwise, whatever you do here cannot be saved, right? Because the laptop is full, the memory is full. But if you buy this extension, you can actually save some of your files here. All right. So this extension is now giving power to this laptop to make it work more efficiently for you. Just think of libraries as the same way, right? They add power to this programming language to make it work more efficiently for us. So there are some operations that we cannot just do using just the Python language. So some people have also sat down and developed various libraries, right? Where we will talk about a number of them. So NumPy is one of them, right? NumPy is one of those libraries which we are going to. So in order to use any library, the first thing you need to do is to actually import that library, right? Import it, right? So import it is just like you can think of it as just loading it, right? Just loading it. You can think of it as loading it. So if you don't actually have it initially, what you can do is to actually store it, right? So let me show you how you can actually store it if you don't have it, how you can actually store it. So in the Jupyter notebook or in your Google Colabs, you can just use this exclamation mark, then you do pip install, right? You do pip install NumPy, right? You do this, but I have it already. So if I run this right now, I'm running it. If I run it, you see that it's giving me over here as a requirement already satisfied because I have already installed it. So I don't need to actually do that. But if you don't have it, you can actually use that command to get it. Okay. Now, what we can do is that after you install this NumPy or after you install any library, what you get to do after that is to actually load it, right? So we use this this command, as you can see over here. We load it by using this import followed by the particular library name. So in this particular case, we are talking about NumPy, so we are loading NumPy. Okay, so from here you can even ignore this one, right? Now you import NumPy, meaning that you have loaded. So now you can use this NumPy, you can work with it subsequently. Okay, now the use of this part, right? Let me do this so that you can actually see. The use of this part is that moving on, right? Moving on. I don't want to be typing NumPy or this word NumPy again over and over again. I don't want to be typing it over and over again, right? So I want to shorten NumPy as NP. Okay, so this NP is just an alias of NumPy. Okay, so I import NumPy as NP, so I just shorten it, right? So NP here is just an alias of it. You could have used any name, right? Any variable name, maybe import NumPy as num, maybe something like that, or import NumPy as pi, or import NumPy as say o, or import NumPy as say b, something like that. Anything you want to use, right? So that subsequently when you see b, you see that b stands for NumPy. Okay, but as I said in the previous videos, if you're giving any alias, if you're giving any variable name, make sure that that variable name makes sense, right? It makes sense in the context that you're using it. So in this case, I'm using NumPy as NP, so that when I see NP, I know that NP stands for NumPy. All right, so if I use just O, it might contradict with some other letter that I would like to use later on. But if I use NP, I know that NP stands for NumPy. All right, so that's actually making sense, and most of the programs you're going to see out there is actually going to see it in this way. So it's quite reasonable to just go by this. All right. So after you do this, you just run. You can use the shift enter to actually run this. Okay. Now let's start by creating something here. Over here, what I'm doing here is that I have my my variable, which is my list. All right, and then I'm creating a list here. Right, we learned how to create a list in the previous video, so I assume that you're comfortable with that. Now I create a list here. What I want to do is that to convert this list into a NumPy array. Now, in order to do that, I create another variable which is going to store this array that I'm going to create. Okay, so I have NP here. You see, now I'm using NP, right? Otherwise, I would have typed NumPy, right? Otherwise, I would have typed NumPy here, but I don't want to be typing NumPy over and over again, so I just use NP. So now I'm using NP dot array, right? So in NumPy, I'm going to create an array out of this list that I created, right? So I'm using the NumPy array here, right? So this is a NumPy array function which is going to convert this list, this my list, right? I created my list here, so it's going to convert this my list into a NumPy array. All right, so let's see. So this n here is just running this. So I could have, I want to actually print this n, so I can do this and then print the n, right? Or I can just leave it like that and then use n. All of them will work perfectly for me. So if I run that, see what I have over here. So if you can recognize what is happening here from the previous video, you can see that this is more like a tuple here, right? This is more like a tuple. So if you go to other tutorials, maybe in the documentation, you might be seeing that NumPy array is a positive. You can see NumPy array is a positive tuple, right? It's a positive tuple. So if you remember this from the previous class, we talked about tuple, how to create a tuple, right? So this is more like a tuple, okay? And you can see there is an array over here. Now, if we check the data type here, right? So let's check the data type so that we will be sure whether we created an array or not. Okay, if we check the type of this, right, we can see that it is a list. Okay, with this one is a list here. Now let's check the type of this n and then see, right? If we do that, you see there is a NumPy nd array, right? That's the n dimensional array. Okay, it's an n dimensional array. Now let's see. Now over here, I first created a list, right? I first created a list. Then after that, I converted the list to a NumPy array. I could have done it straight away, right? So the list, I could have put it here, right? Without creating the list before coming here to convert it, right? Without creating the list and then convert it, I could have just done it, all of them at once, right? If you remember, as we're doing list comprehension, we're trying to make everything to express everything in a single line of code. So over here too, I can do the same thing and then I avoid this line of code, right? So I can just put this one here, right? This list, right? I couldn't just put it straight away here without creating a variable for it before coming to create it. I could have just done it straight away. Okay. So if I do that, you see that I have the same output as all right. Now let's see how this is just a one dimensional array. Let's see how we can create multi-dimensional arrays. Okay. Now, if you see what we have over here, right? If you remember this from the previous class when we created a list of lists, right? We have one square bracket here, right? One square bracket here. Then we will be having this also list, right? So it says list which contains a list, right? So this becomes a list of list, right? So it's a list of list. Now we're going to use this list of a list to actually create multi-dimensional arrays, right? We're going to use this to create multi-dimensional arrays. So don't forget that I told you earlier on, right? Stop here. I told you that we can just create it straight away, right? We can create it without actually creating a list before converting it. We can just create it like that. So that's what we are doing over here. We are creating this list of list, and then after that we convert it to a NumPy array. Okay, so if we do that, you see what we have over here. we have this, right? We have this, which was this one, and then we have that, which was that, and then we have this, which is that one. Okay, don't forget we have our square bracket here, and this time is an array. Okay, it's an array. So this is actually you can think of this as 1 2 3, right? As 3 by 1 2 3, right? By 3 by 3 array, right? So this is a 3 by 3 array, right? So unlike the first one that was just a single array. All right, now if we check the shape of it, you see that we have 3 by 3, right? That's 3 rows and 3 columns over there. All right, now let's see what we can actually use this range for. If you remember the previous class, right? So when we're doing the introduction to Python, we actually talked about a range, right? We talked about what is called a range, right? We talk about a range where we give a range of maybe from 0 to 10, right? If you remember, range from 0 to 10, then it will generate this range for us. So this one is going to be like 0 1 2 3 4 5 6 7 8 and then 9, right? That's 10 numbers for us. 1 2 3 4 5 6 7 8 9 10. Okay, so we dealt with this one in the previous class. Now over here we are using a range, right? We are using a range from NumPy, right? We are using a range from NumPy. And what is this arrange is going to do for us? Let's see the output that we'll be having over here. What this is going to do for us is almost the same thing as the range, right? Almost the same thing as the range that we're having, right? So if it was range 10, just like I just showed you, right? So this is going to be 0 1 2 3 4 5 6 7 8 9. So don't forget that the last one will not come, so you still start with the first, but it will end at 1 less than the last number that you give here. But it's going to give you 10, right? It's going to give you 10 numbers over here. So you can see that it's almost the same thing, right? But this one we are generating it from NumPy, right? So NumPy is also having this function arrange, right? So that you can actually use to do that. Okay. Now let's see what we can actually do. So this one is actually the same thing as that, right? If you remember from the range class in the previous class, it's just the same thing, right? So whether you give the 0 or you don't give, Python would assume that it starts from 0. So even if you do a range, right? Even if you do a range, say 20, right? Python will assume that you want a range of 20, 0 to 20. Right, and it will generate those numbers for you. Okay, so you can either give or you can either ignore it, but the Python will still understand it, and the output is still going to be the same thing, right? But don't forget that in this case we have array here, right? So this is a NumPy array, right? This is a NumPy array because we are generating this from NumPy. So this is a NumPy array, unlike this one that was just giving us the range function that was just giving us range of numbers, right, which was not an array. But in this case we're having a NumPy array. Okay, now you can see this one. Okay, so this is what we were dealing with in the previous class. Okay, we give this range, right? We give this range, and then we print whatever is in the range. So you see that here we have 0 all the way to 9, right? But this one, you can see that we have it in the form of a NumPy array, right? We have it in the form of a NumPy array. So that's basically the difference that you can find between this range and then the range that we're dealing with in the previous class. Okay, so let me hide this one, right? So let me hide this one and then we can move with that. Okay, so this is what I just did. Let me hide it I actually wanted to talk about this. Okay. Now, in the previous video, when we gave this one, and then we say that if we want the interval or we want the jump, we can actually specify which jump that we want. So if we do this, right, then it's actually going to give us in this form, all right, which is 2024. So instead of previously where we were having 0, 1, 2, 3, 4, 5, 6, 7, 8, right? This is 7, 8, and then 9, right? So that was a range of, right? That was range 0 to 10, right? This what it gave us. Now, if we give a condition that jump twice, right? But depending on the jump that we want, right? Depending on the jump that we want. So if we do that, then it's going to start from 0, then it will jump 1, 2, then it will print the 2 for us, then 1, 2, then it will print 4 for us, then 1, 2, then it will print 6 for us, then 1, 2, then it will print 8 for us. Okay, so that's why you have 0, 2, 4, 6, and 8, right? If you specify this to be let me get rid of this. If you specify this to be, say, 3, right? If you specify this, you see that the jump is now 3. You can also think of this as multiples of 3, right? Multiples of 3. So it's the same thing that we are doing over here, right? The same condition that we are giving over here. All right, the same condition. So if you see the output is 0, 2, 4, 6, and then 8, right? 0, 2, 4, 6, and 8. And this one is an array, right? This one is an array. Unlike this one that it will just print just the numbers for us. Okay, now this function zeros, right? So there's a use for this. I mean, everything that I'm showing you here, we're going to be using it subsequently, right? That's why I actually want to introduce you to these concepts so that as we encounter them, they will not be new to you. Okay, they will not be new to you. Now you might be encountering a situation where you need to just generate an array of zeros, right? You need to just generate an array of zeros. So now in that case, what will help you to do is this zeros function, right? That you can just generate an array of zeros. Okay, you can just generate an array of zeros. So with this zeros function present in NumPy, right, you can actually do that. You can actually generate array of zeros. So now if we run this, let's see the output that we have. Don't forget that we are given here 100, right? So it's actually going to give us 100. Let me just reduce it so that you can actually get to see. So let me make it say 50, right? Now you can see that we have all of them to be zeros, right? We have all of them to be zeros. So np.zeros will actually generate this array of zeros for us. Okay, to generate this array of zeros. Now, what if you want to generate ones? Right, you can also do that, and then you can even shape it and then say maybe I want it to be a 3 by 3, right? Just like we're doing up here, right? Just like we're doing up here, we're seeing that the shape of it was 3 by 3. We can do that, right? You can generate ones and then specify the shape, right? So if we do that, you can see what we have over here, right? You can see the result that we have. You can see that we have 3 rows, which is this, that, and then we have these 3 columns. So that's going to be the dimension of this, right? That's going to be the dimension of this arrays. So you can use ones, you can use zeros, depending on what you're trying to actually achieve. Okay, depending on what you're trying to achieve. Now you can use what is called the eye. What will the eye actually do for us, right? This is what the eye will actually do for us. Now if you see the diagonals, right, the eye will actually help us to generate the ones at the diagonals, right? To help us to generate ones at the diagonals, whilst all the rest, right? While all the rest we see here, everything else is 0. Everything else here is 0, right? Except the diagonals, everything else is zeros. Okay, so that's what the eye function will actually help us to do. All right, and it's actually something important that we're going to encounter later on, right? So take note of it. If we want to generate an array which is having diagonals of 1s and then the rest being 0, what we can use to accomplish this as fast as possible is the eye function. Okay, what we can use to accomplish this as fast as possible is the eye function. All right, so take note of that, and then Over here, I'm using this arrange, and I'm going to actually show you something over here. All right. Remember that in the previous class we talked about this lne, right? Lne function, right? To check the length of some of the variables that we created. We can do the same thing over here. Now we are using np.arrange, right? As we talked about arrange here, to generate these numbers for us, starting from 0 to 50, right? So as I said, the last one will not actually be counted, right? So it's to start from 0 all the way to 49. All right. If as you can see over here, let me open this so that I'll show you. All right, as you can see, so it will start from 0 all the way to 49, right? It will not get to 50, right? So it is actually always 1 less than the last number, right? It's 1 less than the last number. Okay, or the last number, actually the last number minus 1, right? That's way. So if you can see here, starting from 0 ending at 49, right? Ending at 49. So that's what it's going to generate for us. Going to generate numbers from 0 all the way to 49. Now if we check the length of this, you see that we have 50, right? We have 50. So if you have a huge data set, right? If you have a huge data set, maybe this one we can spend time counting it, right? But if we have a huge data set, we can just use this len function here to check the length of that data set, and then we see how many data points that we have over there. Okay, so this len function is actually going to help us subsequently. All right, now let me get rid of that. Okay. Now we have this array which is numbers from 0, right? From 0 to 49, right? This is 50 numbers over there. I can reshape this. Reshaping means what? I can reshape it, specifying the row that I want and then specifying the column that I want. Okay, so I'm specifying it into 5 by 10. Just think of it that way. Instead of rows and column, just think of it as 5 by 10. 5 by 10 meaning what? You see that we have this 1, 2, 3, 4, 5, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you see this. Let me push this a bit. Yeah, you see that this actually makes a bit sense to read than what we were having, right? Than what we were having up here. Right, so this is the same thing here. This is just the same numbers that I have here, right? It's the same numbers that I have here, just that I'm reshaping it into this 5 by 10, right? I'm just reshaping this into this 5 by 10 dimension. Okay, that's what I'm actually doing over here. Now, I will show you another way that you can also do that, and the difference that you can do that. We're going to encounter it very soon, but let's talk about this Linspace over here, right? Just let's talk about this Linspace over here. Now, we talked about arrange, right? We talked about arrange where we can use to generate numbers from 0 to 50, right? That is all numbers or integers. Now, if you want to generate like decimal points, right? If you want to generate like decimal points, you can also use the Linspace, right, which will give you an evenly, right? It will give you an evenly spaced, right? Evenly spaced values, right? So in this case, you want to generate evenly spaced values from 10, right, to 7. That is between 10 and 7, right? Between 10 and 7. So for that, we use this Linspace, right, which is going to give it to us in this decimal form, in this float form, right? In this float form. Remember that when we use the arrange, right? When we use the arrange, we get it in this integer form, right? We get it in this integer form. But when we use the Linspace, we get it in this float format. Okay, we get it in this float format. So we're generating over here. We're generating 10 numbers, which are 10 evenly spaced values between 0 and then 7. Okay, between 0 and then 7. All right, now if we check the length of that, we see that we have 10, right? We have 10 numbers just like we specify over here. So over here we can specify as we want. So not that it's just these numbers are going to be generated between 10 and 7, but you can specify as you want. So I can specify, say, 10 numbers, right? 10 numbers, evenly spaced numbers should be generated from between 0 and then 7. If I do that and I run it, you see that I have 20 numbers over here. If I check the length of that, you see that I have 20, right? I can generate 100, can generate 100, right? So it depends on what you want to do, right? It depends on what you want to do. It's all flexible. So I will put this this notebook on the platform. You can play with it as you want. So you can play with it with everything that I've showed you earlier on. You can play with all of them, right? You can just be changing all the numbers as you want, okay, as you want. So that's what I wanted to actually reemphasize. Now I'm going to show you this resize. Now we talked about reshape, right? We talked about reshape. Now I'm going to show you resize, and then you actually get to know. Let me reduce this. Let me reduce this, right, to just the periods that we have, right, 10. Now if I do the resize on that, right, you see what I have. So almost the same thing, like what we were having here, right? Almost the same thing, right, like what we were having here. Now let me show you. We have earlier on we had this. We generated this np.arrange. We used that to generate this 50 numbers. Then we use reshape to reshape it to 5 by 10, right? And then over here we generated numbers between 0 and then 7, right? 10 numbers. And then we are using resize to resize it to 5 and then 2, right? Make sure that if you're doing either arrange or resize, make sure that the numbers that are given inside there, right? So if you're using reshape, if you multiply those numbers, it should give you the length of what, or the total number of what you have generated, right? So over here, I have 50 numbers. Now, 5 times 10 will give you 50. Now, if I do say reshape to 511, let's see what I'll have. I'll have an error, right? Cannot reshape array of size 50 into shape 5 by 11. It cannot do that, okay? So what you can actually do is actually make sure that whatever you're doing is, whatever you put here is actually can be multiplied to get the total value here, right? It's not necessarily 510, but I can also do 10.5, right? I can also do that in it to work for me. All right, so far as it's a multiple of 50, it will work for me. All right, it will work for me. I can do 25.2, right? I can do 25.2, right? I can do 25.2 and it will work, okay? Or 225, right? Either of them is going to work, right? Either of them is going to work. So let me stick to this 510, right? Let me do that. Make sure that it's a multiple of that. That's what you need to do. Now, if I do reshape, what reshape will do is that it will just reshape what is here, right? Without changing the original one. Now, if I run the again, right? If I run the again over here, okay, I have this one. Let me actually run this one. Okay, it's actually mn, right? I have different mn over here. So let me run this, and then let me get rid of that first. Then let me reshape it. Okay, now I've reshaped it. Now if I run this mn, right, you see that I still have it in the same format, right? Let's just watch what I did. I first created this, right? I first created this, right? Then I got this output. Then I reshape it to 5 by 10, right? I reshape it to 5 by 10. Now, after reshaping it, if I run it again, right? After reshaping, if I still run it again, I still get the same original data set that I created, right? I still get the same data set that I created. So what it will do is that it will just reshape it for you, but not, it will do nothing to the original data, right? It will do nothing. So your original data will still stay intact. Okay, if I want to store this or save this reshape, I can create another variable here, maybe n, right, or m, right? I can create it here. Then I'll store this inside there. That's one thing that I can do. So maybe over here, right? Over here, I can store maybe a new variable. I can create a new variable, right? I can call it new variable. Right, then I run it equal to, sorry, new variable equals, right? Then I run it. Now if I do this, right, and then let me show you what I have in the new variable. Now I have this one, okay? But my original data that I created, which is mn, is still intact, right? It's still intact. Okay. If you use the resize, automatically it alters the original data set, right? If you use the resize, it automatically alters the original data set. Okay, so I created this O, right, which contains random numbers from 0, which contains evenly spaced numbers from 0 to 7, right? 10 evenly spaced numbers from 0 to 7, right? If I do that and then I use resize on that, right, if I still run O again, let me come here. So I'm going to run this, okay? Then I'll run the resize again. Then from here, let me create this, and then I'll show you the O, right? Now you see the O is the same thing as the resize, right? It's unlike this one where I did I created this, I reshape it, right? I reshape it, but if I run the original, it's still the same shape as the original, right? But if you use resize, it alters the original. So that's the two differences that you need to know: resize and reshape, right? One alters the original, one does not. So resize alters the original, reshape does not. Okay. I gave you an assignment here for, I think I have already explained that, so there's no need to doing that. Now let's see how we can generate some random numbers over here, right? Let's see how we can actually create some random numbers over here. So over here, I'm using this random. So you can see NP, right? That's my NumPy. Then I'm using random.rand, right? I'm using random.rand. Then whatever random numbers that I'm going to generate, I'm going to reshape it to 3 by 2. Now what is happening over here is that I'm going to generate some random numbers which range from 0 to 1, right? Which is between the range of 0 and 1, right? So to generate those random numbers, I'm using this function random.rand to do that, right? And I want to reshape it to 3 by 2. Okay, so if I do that, see the numbers that I have over here. These are just random numbers that I have, right? These are just random numbers that I have here. I have 0.4, I have this 0.9, this 0.7, this 0.38, this 0.93, this 0.87. So all these are just random numbers that I've been able to generate it. Then I use 3 by 2, that is 1, 2, 3, 1, 2, right? To just reshape it to 3 by 2, right? To reshape it to 3 by 2. Now if I run this again, right, just watch that we have, let's just keep our eye on this, right, so that you actually get to know that I'm generating random numbers. They are not consistent, right? So consistent. So I have 0.41 or 0.92, right? So if I run this again, you see that now I have 0.68, 0.38, 0.08. If I run it again, see that now we have, let's just keep our eyes on this so that we can track it, right? I have 0.68. If I run it again, I have 0.05 now. If I run it again, I have 0.83, right? If I run it again, I have 0.86. If I run it again, I have 0.71, right? If I run it again, I have 0.84. So it's keep on generating random numbers for me. So if I want to generate just any random numbers and work on it, right? You just work on it. Maybe I just want to create some dummy values or some dummy data set and then work on it. I can use this random.rand to actually generate that, right? And all these numbers are going to be between 0 and then 1, right? All these numbers are going to be between 0 and 1. Okay, so that's what random.rand can actually help you to do, and you can reshape it as you want, right? So maybe I can change this one to say 5, maybe 5.3, right? Maybe 5.3. If I do that now, you see what I have here, right? You see that I have if I do that, I see that I have 1, 2, 3, 4, 5, and then 1, 2, 3, right? So you can just reshape it as you want. Depending on the shape that you want, it will generate random numbers for you like that, okay? To generate random numbers for you. So there is one important thing that you need to also note. Okay, now I'm going to show you this one too. Just watch the difference that we have over here. Let me open this so that it will be a bit clear for you. Okay, now see what we have over here. We have random.rand. Now I'm going to use random.randn. Okay, I'm going to use random.randn. All right, now what is the difference between random and then randn? What random.randn would do is to actually return samples from standard normal distribution, right? Standard normal distribution. What we're doing was actually from the uniform distribution, right? So in the uniform distribution, we have the mean, the mean to be 0 and then the standard deviation to be 1. So we want to generate numbers between the mean and the standard deviation, right? So which is between 0 and then 1. But if from the standard normal distribution, we can actually generate. So if I show you this one, we can actually let me zoom out a little bit for you. Okay, we can actually generate numbers, right, which will be either on the negative side or on the positive side, right? So that was actually going to be in the standard normal distribution. Okay, so this one can actually go beyond 1, and it can go beyond -1, right? So you can see that we have -1 here, right? We have some negative, so we have some negative values, and then we have some positive values. So all these are just random numbers, right? Unlike this one that is always going to be between 0 and then 1. Okay, and then I'm using the reshape, this the same thing. So 1 2 3 1 2 3, okay, for us. Okay, so that's what this random.rand n is actually going to do for you. If you use the rand n, it's going to you're going to get positive and negative numbers, right, all together. If I run this again, don't forget that we have 0.72. Let's keep our eye on that. If I run it again, you see that I have negative 0.27. If I run it again, right, let me go there. If I run it again, you see I have 0.47. Right, so it's keeping on generating negative and positive values for me. You see now I have 1.4, so you see 1.4 somewhere here, right, generating either positive or negative numbers from the standard normal distribution for me. Okay, so that's what the random.randn will actually help you to do. Now, see what I'm going to do over here too. Now I've talked about this. I've talked about these two. Now I'm going to add another one. Right, I'm going to add another one. I talked about random.rand. Then I talked about random.randn. Now I'm going to talk about random.randint. Okay, now you see the difference over here. Now what would random.randint gives us? It will return random integers, right, from low, which is low is this low, you give a low value, to high, right, to this high, just like we're giving range. Then we give, say, 0 and then 10, right? We give 0 and then 10, that is, it will generate numbers which are between 0 and then 10 for us, right? It will generate numbers between 0 and 4. So 0 is the low, 10 will be high. So the same thing, 4 will be low, 15 will be high, right? So these are just random numbers that I'm putting there. You can change either of them, okay? You can change either of them. So that's what random.randint is going to actually do. So it's going to generate some integer values for us. Now you can see what we have over here. They are all random numbers. You see we have 5 11 14 12 6 11 6 10 9. All right, so inconsistently it's going to generate these integers for us. So all these integers are going to be between or from 4 to 15, right? Between 4 and 15, inclusive of 4, exclusive of 15. Okay, it's going to generate 10 random numbers for us. Now if I say maybe start from 2 all the way to, say, 20, right, all the way to 20, and then generate 15 random numbers for me, right? If I do that, now you see what I have. The numbers I have here are between 2 or from 2 to, say, 20, right? From 2 to 20, and they are all 50. They are 15 numbers, right? If I should count it for you to see, right, you see that we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, right? So 15 numbers that we have here, right? So in order not to count, maybe I could have just used the length. I showed you how we can use the length. So if I use let me even do it over here, right? If I use, say, len, right, then I use it on mn, you see that we have 15. Okay, so it is going to actually generate 15 random numbers between 2 and then 24 hours. Okay, now I can use the reshape over here. Remember, if you use the reshape, it will just going to reshape it. So let me run this reshape again. Let me actually run this, and then run let me see, cannot reshape. Okay, so we have 15 over here, 15. So we are supposed to do either 3, right? This one is supposed to be 3. Remember that I told you whatever you're giving here should be multiples of the length, right? So that's what it was giving us error. Okay, now you see that we have it here, 5 by 3. Okay, now this one too is a different way that you can actually use. So from 0 to random numbers from 0 to 10, right? And then we are given the shape as 4 by 3, right? So instead of generating the random numbers and then later come and use the reshape, right, we can do all of them on one line, right? So on the same line of code, we can do the same thing. So random numbers from 10 to between 0 and then 10, and then we reshape it at the same time to 4 and then 3. So That's 1, 2, 3, 4, and then 1, 2, 3, right? So that's what you can actually see. So we can do all of them on the same line. Okay, let's see how we can actually perform indexing and then slicing, right? Just like we did in this in list and then tuple in the previous classes, right? We can do the same thing for this over here. Now let's generate this random integers over here. So between 4 and then 15, we're generating 10 random integers. Okay, so if we do that, this is what we have, right? This is what we have. Now if we say we want to actually select the item which is at index 1, right? At index 1, let me open this so that you will see what is there. Now what is happening here is that at index 1, so Python will start indexing it. I actually want to change this. Python will actually start indexing it from, say, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Right, that's 10 items, right? Or 10 data points, random integers being generated for us. So at index 1, what is there? This is index 1. At index 1, we have 8. That's why our output is what? 8 over here. Okay, at index 1, we have 8, so our output is actually going to be 8. Now at index -1, remember in the previous class we talked about negative index, right? If I show you this one here, we talked about negative indexing, right? We talked about negative indexing. So if you have a data points being or list being listed like this, the last one is actually indexed as -1. Okay, so if you want to use negative indexing, then the last one is actually -1. Okay, the last one is actually -1. So over here, let me go down. Over here, if we use -1, right, so we can actually do it this way, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, and then we can also use negative indexing, right? We can use negative indexing. So this one becomes 1, this one becomes -2, -3, -4, -5, -6, -7, -8, -9, -10. Okay, that's how it is. So if we want -1, then it's actually supposed to give us 6. So you can use either mn, that's our variable name, of -1, right, of -1, mn of -1, or right, or we can use mn of 9. They're all pointing to the same thing. So this 9 is pointing to the same thing. This -1 is also pointing to the same thing in memory. Okay, so we can use negative indexing, we can use positive indexing. Okay, if we do that, you see that we have our 6 over there. Right, we have our 6 over there. We can also select within a range, right? So from index 0 to index 7, right? What is there? Let me open this so that it will become clear when I do this. So from index 0, 1, 2, 3, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so from index 3 to 7, remember that it's always 1 less than the last number that you give. So basically it's going to start from index 3 to 1 less than index 7. So index 7 minus 1, that's going to be -1. That will be at the one at index 6. So index 3 is this, right? This is index 3. So we need to select 9, 5, 15, right? So 15 and then 13, right? At 13. Now it's not going to count the index 7. Remember, it's always 1 less than that. So it's actually going to be index 3 to index 6. So that's what you're going to have. That's why you have this. We have 9, we have 5, we have 12. That's 12 over here. It's actually 12, and then we have 13. Okay, that's what we actually have. Okay. Now we can also do this, right? Say from index 3, select everything after that. So when we get to index 3, 0, 1, 2, 3. So from index 3, we select everything, right? We select everything. That's what this one is actually showing us, right? So from index 3, right? Index 3 is 9. That's 0, 1, 2, 3. So from 3 all the way to the last one. That's what is going to happen. So you can also do that. Then we talked about negative index. Okay, we can also do this, right? So from index 5, then we also use the reverse, right? So we also use the reverse. So if I do this for you, right? Let me open this so that it become clear for you. So at index 5, we have index 0, 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, right? And then the negative indexing is negative 1, negative 2, negative 3, all the way, right, to the last one. Now, what we are saying is that at index 5, so at index 5 is 12, we have 12 there. And then at index negative 2, at index negative 2, we have 6. But don't forget that the last one will not actually count. It's always the last one minus 1. So this is actually going to be index negative 3. So it's actually going to be 12, 13, and then this 10. So 12, 13, and then 10. That's what you have over here. 12, 13, and 10. Okay, so you can mix the positive and the negative indexing also when you are doing your indexing, right? So you're actually going to need this, right? When you're doing slicing in some data frames, you're going to need these skills. So that's what I'm showing you earlier on here, so that when you encounter such problems subsequently in your data set, you actually know what to do. Okay. We also talked about arrange and resize, so I'm not going to spend much time over there, right? I'm not going to spend much time over there. Okay. So all these are just the same thing. Arrange and resize and stuff like that. So let me talk about this slicing over here, right? Maybe that's going to be a bit sensible. So over here we just created, right? We used the arrange to create 64, right? To create 64 random numbers, right? So I mean, it's not a random numbers actually, from numbers ranging from 0 to 63. Remember, the last one will not actually come, right? So 0 all the way to 63. Okay, that's one less than the last one that we give. Okay, then after that I'm using the resize to resize everything. Now don't forget that this 8 by 8 is just a multiple of 64, right? So if it's a multiple of 64, it will not work. If I do 8 by 7, I'll get an error. Okay, if I do 8 by 9, I will get an error, right? So it's supposed to actually be multiple of what you have given over there, right? So it's not specifically 8 by 8. If I do 64 by 1, it's also going to work, because 64 by 1 is also a multiple of of 64. So you see what I have over here. I'm going to have 64. You can think of it as 64 indexes or 64 rows by 1 column, so only one over here, right? So it's 64 by 1. Okay, you can think of it that way. So let's stick to our 8 by 8, which actually is going to make sense. Now what I'm going to do is to perform a slicing on this, right? Earlier on I was just doing it on just one dimensional array, right? So I'm going to do it by 8 by 8 dimensional array over here. So if I want to select this 2 by this 3, what does this mean at index 2 and at index 3? Now this first index, right? This first index that you're seeing over here is the index of the row, right? So at this one is actually like this. Let me bring this one here. Let me see. Actually, use that. Okay. Now, what is happening over here is that this row is actually indexed as 0. This row is indexed as 1. This row is indexed as 2. Right? 3, 4, 5, 6, 7. So that's how the index is being done. The same way 0, 1, right? 2, 3, 4, 5, 6, 7, right? The same way. So if I want index 2 at row 2 and then index 3, that's what is going to happen. So 2 is this one, and then 3, right? So this and then 3, where do they meet? Right? Okay, I think I have to run this again because I've actually regenerated this. So let me run this one again. That's what is giving me complications here. Okay, so now let's see what we have. Let me zoom a little bit out. Okay, so this is what we have, or let me do it this way. I think it's a bit clear for you. Yeah. So this is what we were talking about, right? Let me see the color with the pen I have. That's fine. Now, I was saying that this is, I think this blue works better. This is at index 0, this is index 1, this is index 2, this is index 3, right? Index 4, index 5, index 6, index 7. Okay, just the same thing here. 0, 1, 2, 3, 4, 5, 6, and then 7. Okay, so at index 2, right, at row 2, you can think of it that way. At row 2, which is this one, so at this row, right, at row 2, and then the column, right, you can think of this as the column, right, at column 3, at this. So where do they meet, right? So if you want to trace, they meet at this, right? They meet at 19. So that's why you have 19 over here, right? That's where they meet, and that's what they have actually given you. Okay, that's what they have actually given you. Now, if I show you this one, right, this one, let me zoom a little bit out. Now, what this one is saying over here is that, remember that we just did a range, right? You can slice within a range, right? Just like we were dealing with over here, right? Just like we're dealing over here. So we're going to combine the same intuition over here. So what is actually happening over here is that I want at the index 0 and at the index 4, so you can think of it that way. So 0, 1, 2, 3, 4. So here, right? I wanted that here. But I want I want to select within a range on the column. I want to select within a range of 2, right, to all the way to 5. But remember, it will actually end at 4 because the last one will not come. So here I have 0, 1, 2, 3, 4, right? So here, right, pointing here, right, 4, and then 5, right? No, actually from 2, right? It's actually from 2. So we have 0, 1, 2. All right. So from here, we have 2. Don't forget we have 2. Okay, we have 2. So where do they meet? They meet at this 34, right? So you see that we have 34 here. Now I want to slice all the way to 5, right? So I want to slice. So this is 2, 3, 4, right? 3, 4. So don't forget that the 5 will not come, is one less. So 34. So where is that 34 is going to land? At 36. Right, so within that range, it's going to select for me. That's why I have 34, 35, and 36. So it's going to select that range for me. Okay. So at this row 4, right, and then I can select within a range, right? I can select within a range. Okay. So I hope this also makes sense to you. All right. Now let's see what we have over here, right? 2, and then select everything at the back for us. From 2, starting from the 2, just like we're dealing with over here, right? Just like we're dealing with over here. Starting from 3, we select everything. So over here, the same intuition. Starting from row 2. So row 2 is where? 0, 1, 2, right? So 0, 1, 2, right? Starting from 2. Let's see the output that we have over there, right? Select everything. So it's actually going to, we did not give any specifications for row, so for column, so it's going to select everything. So 0, 1, 2, let me run this again. Yeah, 0, 1, 2, right? 0, 1, 2 over here. So this, let me zoom out so that you actually get to see what we are selecting. Okay, so 0, 1, 2. So starting from here, we're going to select everything, right? We did not specify any column, so it's going to give us everything over here. That's what we are going to get. So that's just the same thing that you're having over here, right? It's just the same thing, right? If you spot, we have 16 here. We have the same 16 here. We have 63 here. You can check. We have 63 here. We have 23. So you can check the corners to see that everything is working. Okay, so it's the same thing that we've been able to extract from this. Okay, now let's see what we can do. Now I'm combining this 2 times, right? Remember over here I did not specify, right? I did not specify say maybe 5 from 4, then select everything. I did not do that. No, so we can also do that. So from this row 3, so 0, 1, 2, 3. So it's actually going to start from here. Let me see if I can zoom out and then get everything together for you to see. Okay. So 1, 2, 3. 0, 1, 2, 3. So actually here is where it's going to start. And then from the column, so 0, 1, 2, 3. That's actually going to start from here. So where do they meet? They all meet somewhere 0, 1, 2, 3, right? So they all meet here at 27. They all meet here, right? So from the row is saying that from everything here, select everything, and then column is saying that from everything here, select everything for me. So we're going to get this portion. We're going to be able to extract this portion, and it's the same thing that we have over here. Right, it's the same thing that we have over here. If you want to check, there's 27. So what do we have? Is 31. So what do we have? 59. What we have? 63. What we have, right? So you can check from the connects and then see that everything is working perfectly. Okay. Now moving on, see what we can do over here. All right, what I'm going to, let me run this. What I'm doing over here is that I go into this that I created, right? This 8x8 array that I created, right? If I go in, anything that is greater than 25, I'm going to extract it, right? So anything that is greater than 25, I'm going to extract it. If I do, don't forget that I'm using, let me undo. Don't forget that I'm using this mn outside again, and then inside I'm using mn again, right? What I'm trying to do is to get the numbers. If I don't do that, right? If I don't do that, see what the output I will get. I'll be getting some true or false, okay? Where false means that the number that is there is actually not greater than 25, right? So if we want to verify, right? If we want to verify, so at the first you see that we have 0 there. So 0 is not actually greater than 25, so you have false. 1 is not greater than 25, you have false. Right, until it encounters a number which is greater than 25. So if you see, let's see a number which is greater than 25, right? This number, this 26. This 26 is the one which is greater than 25. So you see that at that point, right? If I do this, if I trace it, you can see, right? So this 2 here, right? They will be false over there. All of them will be false. But starting from this 26. Right, it will start saying true over there, so it will start cutting it from here. So all these numbers are greater than, right, all these numbers are greater than 25, right? So you will be seeing something like that, right? All these, the ones that are greater than 25, right, you'll be seeing them like that. Okay, you'll be seeing them like that. So it's just the same thing that is going to, the same condition that is going to give over here, right? So, but you'll be getting true or false, but just in case you actually want the numbers, right? You actually want the numbers and not true or false, then in that case I can do it this way, that it will give me the numbers. Now you see that it has actually extracted all those numbers that are greater than 25. Okay, so starting from 26, right? Starting from 26, all those numbers that are greater than 25 will be extracted for me, and that is what exactly that it has actually done over here. Okay, so from 26 all the way down, right? Starting from 26 all the way to 63, right? So that's what is going to happen here. 26 all the way to 63. Okay. Now this one is basically the same thing. It's just the same thing as we did over here, right? It's just the same intuition that you can actually use, right? So let me talk about this one rather. Let me talk about this one. I think let me do this and see. I think I should have pushed this a little bit. Okay, that's good. Now if you see this one here, right, this one we talked about is the same thing that you have here. What I'm going to do is that I'm going to do what is called the broadcasting, right? I'm going to cast numbers in here. So every number, right, every number that is greater than 25, right, every number that is greater than 25, I'm going to rename it as 25. So all the 25s will be renamed as 25, right, or be replaced with 25. So if I run that, you can see the output that I have over here. So if I compare this with the original, let me run this one so that you can actually see. So in the original one, we're having 26, 27, 28, 29, 30, right? So all these numbers from here, everything here which was greater than 25 will be replaced with 25. That's what is happening over here, right? That's what we refer to as broadcasting, right? So that is what is actually going to happen here. So everything that was greater than 25, right, has been replaced with 25. So the last one was actually 63. So even the 63 will be replaced with 25. Okay, even the 63 will be replaced with 25, right? And you can continue doing your slicing, all the slicing that we've been talking about. Okay, now let's talk about how we can create a copy. So if you have, I mean, this broadcaster, I think I should have actually bring it up, right? I should have brought it somewhere, yeah, because this is actually a broadcasting that I was doing over here. So let's see how we can actually create a copy. So this one way that we can create it, right, by selecting some, right, just slicing some part of the data that we have already and then store it in another variable, and then after that we can actually work on that variable. Okay, we can actually work on that variable. Now if we do this, see that we have 25. We've been able to extract all those 25s, right? So the ones that were having 25s in here, we are able to extract that. So I'm specifying that we go into this that we have here, right? So we have 0, 1, 2, 3, right? So from 3, so we're going to select everything over here, right? And don't forget this 24 will not come because I'm also giving a condition for the column that 1, 2, 3, right? So if I show you this, let me write it so that it will be clear for you. All right, so what I'm saying is that at index from this 0, 1, 2, 3, right? So from this part, right, and then 0, 1, 2, 3, right, from this, right, where do they meet? They meet at this 25, right? So I'm saying that select everything here, right? That's why you see 3, this column at the back. So I want to select everything, and then I also have 3 columns, so select everything from here, select everything. So we're going to actually be able to cut this part, right? So this is the part that we've been able to cut over here, right? And then we cut that, and then we store it, or we actually extract that, right? And then we store it in another variable. We store it in another variable called mm1. All right. Now if we come here, right, this another way that you can create it. So this one was one way that you can create a copy, right? And this is another way that you can actually create a copy. Now why do I want to show you how to create a copy? Just in case, I mean, let's take for instance, you have a data set, you've loaded the data set, and then you want to work on it. You are not even sure what you want to do. You want to perform a lot of data cleaning, you want to perform a lot of data exploration, a lot of data manipulation in there, but you don't actually want to destroy or mess up with the original data that you have, the original data that you have loaded. So what you can do is to actually create a copy of the original data, right? So if you use this copy function, you can actually create a copy. So this is our original data, right? Remember earlier on when we created this, this was our original data over here, right? When we first generated this we store it in what is called mm. So mm is actually our original, right? Since that's what our original data set is stored in, right? So if we do that, right, we can create a copy using this copy function and then store it in this. So this one is actually going to, my copy is actually going to contain the same thing. Remember that we have replaced everything which is greater than 25 as 25. That's why you see this one over here. So this my copy is going to contain the same thing as this mm, right? So this my copy is going to contain the same thing as this mm. Okay, now when we come here, right, we can actually start working on this my copy and then work on it, manipulate it as we want, but our mm is still going to stay intact without being destroyed. So if you work on your data set that you have created, right, if you work on the copy, you can work on it as much as you want. Then later on you can go back and then start working on your original data, that if you want to work on that, or you can still save the one that the copy that you have worked on, right, and then maybe proceed with that. All right, so I talked about list. I talked about this broadcasting earlier on. It's just the same thing that I'm doing over here, right? Just the same thing that I showed you here, right? That's why I said I should have actually brought this one down here. Okay, so I'm just broadcasting anything that is greater than 25 as 25. Okay, so if you do that, you're still going to get the same thing because I've already worked on that one. So let's see which one. Okay, now I'm going to show you an example using a real data frame over here, right? So a real data frame over here. So here I'm importing pandas, right? I'm importing pandas. Then I'm loading a data set. Now I have this data set stored on my desktop, right? That I'm loading here. Okay, I have this data set stored on my desktop that I'm loading here. This data set actually contains it contains a CSV for format of records, right? CSV is nothing but comma separated. So let me see if I showed you over here. If I okay, let me show you from here what the CSV means, right? And if you have watched this video, I'm sure that you are familiar with what CSV is, right? If you have watched the introductory video, then I'm sure you are familiar with what CSV means. So this is how it is, right? This is how it is. Now if you see over here, we have this. You see that we have this ID. Let me use this. Let me get rid of. Okay, you see that we have this ID, then we have this comma here, we have this type, we have comma, we have name, we have comma, we have year published, we have comma, we have main players, we have comma. So this is how every data point is being separated, right? Every data point that we have is being separated with a comma, right? Every data point that we have in is being separated with comma, right? So this is what we refer to as comma separated values, CSV. All right, so for that, if it is a comma separated value, then we use read underscore CSV, right? So that's what we are using in this particular exercise that you're seeing over here, right? That's what we are using over here in this particular exercise. So that's why you can see that I'm using read underscore CSV, right, to read that. So pandas is having this function read underscore CSV, which will help us to read this CSV file, right? I'm using skip rows equals true because I want to skip the first row over there. If the first row is containing some ugly numbers that I did want to actually load it, right? So I want to skip that. That's why I'm using this one. Now, after I read that, I store it in a variable called data. Okay, so I read this, I specify the file that I want to read, which is in a format of CSV. So if it was stored in say XLS, right, so then I'll use read underscore SL, right? I will use read underscore SL, right? We're going to be reading a lot of different data formats and later on, and you will actually realize how we're going to read it. Okay, so after that, I want to see the first 5 rows, right? For that, I use the head function. I use the head function. Remember that I store everything in a variable called data. Okay, so whenever I see data, I know that data contains my data that I'm working on. That's why I said that if you're given a variable name, make sure that it makes sense. Okay, so the head will give us the first 5 rows. That's why you see from 0 to 5. That's the first 5 rows. That's 1, 2, 3, 4, 5, right? So pandas will actually start indexing it starting from 0. Okay, and it will give us in a row, right? We will have rows and then columns, right? So you can think of this as the Excel sheet that you have, where you'll be having rows, right? I mean, or a normal table that you'll be having rows, different rows, and then different columns, right? The same thing that you have in your Excel sheet. That's what pandas will give us. So this is what we refer to as a data frame, right? This is what we refer to as a data frame, right? A pandas data frame, right? You can call it that way too. Pandas data frame. All right, so let's see what we are going to actually do over here. Now I've loaded my data. If I don't want to mess up with this data that I've loaded, right, I can create a copy of it. That's what I was trying to actually show you up here, right? Use this copy function to create a copy. So every single small thing that I've told you here is going to be applicable as we move on, right? It's going to be applicable as we move on. So you see that over here, I'm creating a copy of it. Then I'll store it in a new variable name called data1. So now this data1 contains my original data set. It contains the same thing. So I can now start working on this data1 whilst my data, which is the original one that I loaded, stays intact. Okay, so if I run this, I'm going to get a error. I did not run this first, so let me run that. Then I'll come here. Then I'll run again. Okay, so now my data1 actually contains that. Okay, it contains that. Now I can start working with this data1. You see that I'm using data1 instead of data. My data is actually, or let me actually even use df, just in a form of a short form of a data frame. Let me just shorten it in that way so that the names will actually be different for you. You can actually see the distinction. So now I have a different, I've created a copy of my data and I've stored it in a new variable called df, right? So now I can start working on it. But don't forget this df, right? So let me actually print that one here. If I do df dot head, that's to see the first 5 rows, right? It actually contains the same thing. df, actually there's no f here, dot head. You see that it's the same thing. We have country code, year, medal tally, unnamed 4, unnamed 5, right? It's the same thing. Country code, year, medal tally, unnamed 4, unnamed 5, right? So they all contain the same thing. Just that this that I'm working on is a copy of the original. So the original, I don't want to touch it. Now I'm going to work on df. Okay, now if I do df country, it means that I'm going into this df data frame that I have, and then I'm going into this column. So from df, I'm going into this column. That's what it's actually pointing over here, right? So from this df, I go into this df that I have, and then I select country, right? So I select in df, I select a column called country. That's what this particular thing over here is trying to do for me. So in selecting that, I use this quote, either double quote or single quote, to actually call that particular column. Okay, now if I do that, right, if I do that, see what I have. I've been able to extract this, right? I've been able to extract this. So this is what I have, right? This is what I have. So I went into this, then I into this data frame, then I selected this country column, right? Then I'll be able to extract everything which is in that country column. That's what is happening here. See, that is the same thing. NAN, Great Britain, China, Russia, United States, Korea, Japan, Germany, the same thing. NAN, Great Britain, China, Russia, and the United States. Okay, I think there's some inconsistency in here which I need to, because I have German. Okay. I'm actually seeing the head, right? So this is actually giving me only the first 5 rows. So there's actually Germany there, but you cannot actually see over here, right? So if I see, say if I do say 10, right? I mean the first 20, right? If I see the first 20, you can see that now I can see Germany in there, right? So that's why I see Germany here, but I was not seeing it up there, right? Because I was just seeing only the first 5 rows. Okay, so it's there. It's actually inside there. All right, now I'm not using data 1 again. I'm using df, right? So it's just the same thing that I did above there. So let me comment this one out. All right. Then I'm going to be, maybe I should just maintain that one, so in order not to be changing everything over and over again, right? Otherwise, moving on, need to be changing everything. So I'm just going to remain that, right? Otherwise, I need to be typing everything again. I don't want to be typing it and over again, right? I feel tired doing that. Okay, so what I'm going to do over here, right? Let me zoom out so that you can actually see everything. Now, if you see this column, right? I wish I can open this one so that you can see all of them at once. Okay, I think this is good. So what I'm doing over here, right? That's why we said that 80% of their time, all right, 80% of your time, 80% of your time you're going to spend in cleaning your data, right? You're going to spend in cleaning your data, because when you receive a data set, mostly when the data set will come in different forms. It's not clean, it's not neat. You actually need to spend a lot of time cleaning it and making it ready for further analysis, right? You need to spend time in doing that. So 80% of your time you're going to spend in doing that. Now if you see this column, right, we have country, we have country code, we have year, we have medal tally, we have unnamed, and then we have unnamed 5, right? Unnamed 4 and unnamed 5. Now, if you see how readable these ones are, better if you see this one, unnamed 4, unnamed 5, what is that? We can actually work with that. It doesn't actually make sense. So we want to get rid of that. We want to clean it. We want to make it more readable. So what do? We can replace these names, right? We can replace these names with more readable headings. Okay, we can do that. So if you see what I'm doing over here, right? What I'm going to do is that if I do this, right, if I do data 1 and then I create a list of lists, so you can see that this is a list which contains two different characters or strings, right? two different strings, right? So I have award, then I have award one. So this is going to actually create new columns, right, in our data. So you can see that we have award, right? We have award, then we have award one. So this is actually going to create new columns. Okay. Now, what I'm going to do is that in creating new columns, I want the same input, right? I want the same input. So the input of our named for is the same input I want to give to award, right? And the input of unnamed 5 is the same input I want to give to award 1. So you can see that they all have the same input: silver 17, bronze 19. So the same thing, whatever input is there, they are all going to have the same thing, right? They are all going to have the same input. Now, after that, I can now drop these columns, right? I will not need these columns because these ones contain the same information. So that's one way of doing it. Otherwise, I could have used the rename, right? I could have used the rename function. There's also a rename function, which later on we will be using it, right? We'll be using it. So I could have done it this way. Let me get rid of that. I could have done it this way. Maybe create maybe my df, right? I could have just used the rename function, right? I could have just used the rename function. Then I'll specify I can create a dictionary for that, right? Which or maybe instead of this, I think my pen is actually disturbing. So I could have just used rename. This is what I was writing earlier on, right? Just rename. I specify which columns, right? I create a dictionary for that, and then I say that unnamed, right? I use, it's a string, so I use double quote over there. Then I use unnamed. Don't worry about this one, we're going to deal with that. So if you are not getting it, no problem, right? Unnamed for, I want to rename it to say award, right? I want to rename it to say award. So I can do that. So that will become one key and then one value. Then I'll create another key, which is going to be unnamed 5, right? So unnamed 5 too. So unnamed 5 become a key. Then I create a value which is going to be award 1, right? Which is going to be award 1. So then this one will come, then this one will come. So I could have used this function, right? This rename function to do the same thing without creating new columns over here. And we are going to see this one in action very soon, right? In the pandas class, you're going to see this one in action very soon. Okay, so don't worry about that one. Okay, so I just wanted to show you that it's possible to rename it. It's possible to clean your data. Okay, now if we do that right now, what I'm doing over here is that after I created these two new columns, I'm going to drop these ones because I no more need them, right? I no longer need them because whatever information they contain, the same information these ones are contained, right? So I just created a duplicate of that: 17, 19, 28, 25, 25, 28, 28. So the same thing, the same information they all contain. So I'm going to use drop function to drop the unnamed 5 and then the unnamed 4. Then I'm specifying that they are all located in axis 1. Axis 1 means that they are located in the column, right? They're located in the column. So if I use axis, let me open this one so that you can see. If I use axis equals 0, right? If I use axis equals 0, then I'm specifying that whatever I want to drop is located in the row, right? So whatever I want to drop is in the row, right? But in this case, whatever I want to drop is in the column, right? It's in the column there. So I use axis equals 1, right? If you use axis equals 1, it means that whatever you want to drop is actually whatever you want to drop is actually in the column, right? If you use axis equals 0, it means that whatever you want to drop is in the row. Okay, so take note of that. Now after that, you see that over here we only have these ones, right? We only have these ones, like you can see them, but these ones are gone, right? They've been dropped, right? Just like we dropped them over here. So now we don't have it there. See that from medal tally, we go straight to award and then award 1. From medal tally, we now go here. So these ones are the next, but these ones are no more there. Okay, so we can use this one to also do that. So this is just one way of doing it. But when we get to in the pandas class, you can see that we're using the rename function to actually there are several ways that we can do this. Okay, there are several ways that we can actually rename a column. Okay, so remember that everything that we are doing, right, every modification or every manipulation that we are doing over here, we are doing it in data 1. That's the copy that we created, right? That's a copy that we created in data one. But if you come here, right, if you come here, you see that this is the original one. When we loaded our data at first, right, if you come here, data, right, it was stored in what is called data. So if we now see our data, it still contains unnamed 4 and then unnamed 5. So our original data is still intact. There's nothing that has happened to it because we are working with the copy data. All right, so this one way that you can actually do. So back to NumPy, again. Here we can create a list, and I'll see what I'm doing. A matrix, right? We can create a matrix from this NumPy array, right? So remember that if we have the NumPy array, we'll be having this, right? We'll be having this. Now if I do this, right, I can consider this as a matrix, right? I can consider this as a matrix, right? I can consider this as a matrix as 1, 2, 3, 4 as a 4 by 4 matrix, right? I can consider this as actually 4 by 4 matrix over here, right? I can consider this as a 4 by 4 matrix. I can also use the matrix function to create the same thing, right? Over here, I can use the matrix function to create the same thing. Right, there's a matrix function that you can also use, and then I'll pass in a list, right? I'll pass in a list, then I use the matrix function. So mp.matrix will actually help me create a matrix, right? So if you run the output, you see that it's actually indicating that whatever we created is a matrix which contains list, right? It's a matrix which contains list. Okay, now after creating that, right, you can also use do mattress indexing, right? You can do indexing. So if we see this one, we are saying that index 1 and then column 2, where let's see what is there. Index 1, so 0, 1, right? So this index 1, column 2, so 0, 1, 2. So where do they meet? This, right? So 0, 1, and then 2. So they all meet here at 4. So that's why we have 4 over here. Okay, so we can also do it in that way. These are some of the links that is trying to open. You can also do it in that way. Now, what I'm doing over here, right, just like we did for the 25 as earlier on, right? We did for this as we created a copy, then we said that anything that is greater than 5 broadcast it with 5. But over here, you see that we selected this, that anything that is greater than 25 selected for us, but we want the actual numbers, not the true or false. So that's why I use this one over here. So the same thing that I'm going to do over here, the same thing that I'm doing over here, right? That in my matrix, in my example matrix, I want to select anything that is less than 10, right? And I want the actual values, not the true or false, right? I want the actual values, not the true or false. So if I do that, you see that I have this. If I don't bring this, if I take this one out, let me just run this. If I take this one out, right, then I run this, right, this one is not necessary. If I do this, you see that I have true or false. So only the ones that are less than 10 will be output as true, right? So if I compare this and that, right, if I compare them, let me zoom out a little bit. Okay, if I compare them, right, so you can see that we only have 6, 4, and then 9, which are less than 10, right? The rest are greater than 10, 24, 22, 16, 14, 8, 88, 1400, 23, 21, 30, 100, 54, 32, 33. They are all greater than 100, so they're all before. So is the first one here greater than 10? No, right? It's false. 24 is not greater than, it's not less than 10, rather. 24 is not less than 10, so it's false. Okay, then if you check, is 22 less than 10? No, it is false, right? But if it checks, is 6 less than 10? Yes, that is true, right? So it will give you true, right? But I don't want the true, right? I don't want these true. I want the actual numbers to be output for me, right? So that's why over here I will actually add this, right? So if I do this and I run it to I will be able to extract this, right? I'll be able to extract the 6 and then 4, right? I'll be able to extract this 6, 4, 9, right? Instead of the true or false, right? I'll be able to extract the actual values. Okay, now over here, I can now use these functions, the mean and the median and the standard deviations, right? So I can calculate the mean of this matrix, right? If I use this, I can calculate the mean of the matrix, right? I can also calculate the standard deviation, right? I can calculate the standard deviation. I can also calculate the variance, right? So I can calculate the variance using the val. Okay, so this is pretty much it. This is basically the everything that you will need in regards to NumPy, right? Everything that you will need in regards to NumPy. So moving on, we are going to be using it quite a lot in our subsequent classes, in the machine learning class, and in our data analysis and machine learning and all the deep learning classes, right? So we are actually going to be needing this. That's why I actually want to introduce you to it. So just take time and then manipulate it as you want, right? So I'm going to load this on a platform so that you can actually work with it. All right, I've also given you some links that if you actually want to refer to some information here, I've given you some quality links here that you can actually use. Okay, so see you in the next class. In the next class, I'm going to talk about pandas. So see you in the next class.